Hello students, welcome to another video, and in this video we are going to solve question number 11 to 20 of permutations and combinations. The link to download the PDF will be in the description, as well as at the end I will show you how we can download the updated PDF and my question answer website. So we start with question 11. It says that prove the theorem of Nicomacheus. That is 1 cube is equal to 1, 2 cube is equal to 3 plus 5, 3 cube is equal to 7 plus 9 plus 11, 4 cube is equal to 13 plus 15 plus 17 plus 19, and so on. So the first term here contains one term, second term contains two terms here, third term contains three, fourth contains four, so each term will contain k terms. Okay, here it will contain two terms. Now sum of k terms is 1 plus 2 up to k is equal to k into k plus 1 by 2. So k plus 1 term will begin with 1 plus k into k plus 1 by 2 into 2, because the numbers are increasing by, the numbers are increasing by 2. So for example, this is 1, this is 3, this is, if you put k is equal to 2 here, for the second term, so it will become 2 into 3 by 2, so 2 to cancel, and 3 to the, hang on a minute. So, yep. So this is second term, right? So if this is second term, then what is the value of k here? K into k plus 1 is equal to, so k plus 1 term, this will be equal to 2, right? So when we solve this, then this k square plus k plus 1 will be equal to 2. So k square plus k minus 1 will be the, okay. So here we solve this, k plus 1 term will begin with k square plus k plus 1 and will contain k plus 1 terms, and common difference will be 2. You see this common difference is 2 here, okay? And there will be k plus 1 terms. There should be true for tk, that is tk is equal to k cube. So tk plus 1 on right hand side will become k plus 1 by 2 into 2 times k square plus k plus 1, because that is the first term of on right hand side, plus k plus 1 minus k into 2. So we solve that, we get k plus 1 cube. Okay, now we have question number 12. We have to show that sigma r is equal to 1 to n r times mcr is equal to n times 2 to the power n minus 1. So we let Q1 is equal to 1 into 1 to 0, that is equal to 1. And right hand side becomes 1 into 2 with 2 raised to the power 1 minus 1, that is 0, so that is also equal to 1. We let it be true for n is equal to k. So kc1 plus 2 into kc2 and so on up to k into kck is equal to k into 2 to the power k minus 1. Now we have got pk plus 1, that is k plus 1 c1 plus 2 into k plus 1 c2 and so on up to k plus 1 into k plus 1 c k plus 1. Now we write this k plus 1 c1 as kc0 plus kc1 and this as 2 times kc1 plus kc2 and so on. Okay, there is some typing mistake. This can be written as kck. So 0 is fine. Now what we do is we take kc0 to kc1 up to k plus 1 c k ck. Okay, k plus 1 k ck. And then we collect these terms kc1, kc2. So we collect and we write here. Okay. Once we have done that, we see from analogy from this, what we see here is this is 2 to the power k, okay, and this one will become k into 2 to the power k minus 1. All right, so then we take 2 to the power, and there seems to be some mistake here, okay. This has this has been written twice. So let's see why. Is there any reason why this should be written twice? Give me a moment, I'm checking. So this is from the first terms we collect, okay? And this is k plus 1 times, all right? So this shouldn't be k plus 1 times. This should be up to k times. So that is the first thing I observe. And second, we have this. Okay, let's revisit the problem a bit. We write this as Kc0, Kc1, 2 into Kc1, Kc2, and up to k plus 1, Kck plus 0. And then we write this as Kc0 plus 2 Kc1 up to Kc. Yeah, that is fine. So if you see this, this should be k, okay, or not. Let's check here. So this is k plus 1's kck, okay. So if we write here k plus 1, this should be kck, okay. This one should be k times kck, okay. Now we observe here, before this what will be there? So before this it will be k times k plus 1 ck, okay. So yep, so this would be this much, all right. So that is correct. So once we have that, we can write k plus 1 into 2 to the power k, okay. These two will become k into 2 to the power k, and thus we have pk plus 1. There may be typing mistake in this. Okay, this I'm not sure this is correct. It looks like good to me. Let's take one more minute to resolve this issue. Okay, we split this and up to kck. Okay, so case and this product, that will be, if you look at this would be 2 to the power k plus k into 2 to the power k minus 1. This would be, yep, looks good. Yeah, it is fine. So what we have done here is we have taken one out of this. Okay, this has been further split. It has been split into Kc0 plus Kc1 plus Kc2 plus Kc3 up to Kck, and that is equal to 2k. And what will remain is Kc1 plus 2 Kc2 plus 3 Kc3 up to Kck, sorry, k times Kck. And that would be equal to k into 2 to the power k minus 1, and this would be equal to k into 2 to the power k minus 1. It is correct. There should have been one more step for clarity, but it is fine. Question 30 says that show that sigma r is equal to 1 to n, r times 2r plus 1 is equal to n times n plus 1 times 4n plus 1 by 6. So we put n is equal to 1, we get p1 is equal to 1 times 2 into 1 on left hand side, and which is equal to 3, and right hand side is 1 into 2 into 9 by 6, which is equal to 3. So it is 2 for n is equal to 1. We let it to be true for n is equal to k. So we have got sigma r is equal to 1 to k, r times 2r plus 1 is equal to k into k times k plus 1 times 4k plus 5 over 6. Now we compute pk plus 1. So on the right hand side, we add how much? K plus 1 times 2k plus 3. So we put I is equal to k plus 3. So we add that much on right hand side. We solve right hand side becomes k plus 1 times k plus 2 times 4 times k plus 1 plus 5 by 6. And hence it is proven by induction. We simply say induction instead of mathematical induction. And then we have question 14, which says show that 1 times 2 times 3 plus 2 times 3 times 4 plus 3 times 4 times 5 up to n times n plus 1 times n plus 2 is equal to n times n plus 1 times n plus 2 times n plus 3 by 4. So we let this given expression is Pn and you put n is equal to 1. So that 1 dot 2, 1 times 2 times 3 is equal to 6 is equal to 1 times 2 times 3 times 4 over 4, which is equal to 6. So it is 2 for n is equal to 1. We assume that it is 2 for n is equal to k. So we have this relationship. Once we have that, we add k plus 1 times k plus 2 times k plus 3 to both sides. So our left hand side becomes pk plus 1 and right hand side upon evaluation becomes k plus 1 times k plus 2 times k plus 3 times k plus 4 by 4. Hence, by mathematical induction, we have the result. Question 15 says that show that 1 over 1 times 4 plus 1 over 4 times 7 plus 1 over 7 times 10 up to 1 over 3n minus 2 times 3n plus 1 is equal to n over 3n plus 1. So as usual, we put n is equal to 1 in Pn. So it is left hand side becomes 1 over 4 and right hand side becomes 1 over 3 plus 1, which is 1 over 4. So it is 2 for n is equal to 1. We let it to be 2 for n is equal to k. So we have got this expression for pk. And then we add 1 over 3k plus 1 times 3k plus 4 to both sides. Left hand side becomes pk plus 1. And right hand side we evaluate, which it becomes equal to k plus 1 by 3k plus 4, which is equal to again pk plus 1. Now we move on to question 16, which says that 7 plus 77 plus 777 up to 777 up to n digits is equal to 7 by 81 times 10 raised to the power n plus 1 minus 9 and minus 10. So as usual, we let it to be equal to Pn and we put n is equal to 1. Left hand side is 7, right hand side is 7 by 81 times 10 square minus 9 minus 10. So 10 square is 100 minus 9 is 91 minus 10 is 81. 81 get cancelled. So 7 is equal to 7. So it is 2 for n is equal to 1. We let it to be equal to be true for n is equal to k. So we have this relationship here. Okay, now we add 777 up to k plus 1 digits to both sides. And we have got this left hand side and then right hand side becomes this. Now 777 up to k plus 1 digits can be written as 7 by 9, 10 raised to the power k plus 1 minus 1. And then we evaluate, we get 7 by 81, 10 to the power 10 raised to the power k plus 2 minus 9 k plus 1 minus 10. And thus by induction it is proven. Question 17 says that so that 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 through 1 by 1 plus 2 plus 3 through n is equal to 2n by n plus 1. We let the given expression be Pn and we put n is equal to 1. Left hand side becomes 1, right hand side becomes 2 into 1 by 1 plus 1, which is 1. So it is 2 for n is equal to 1. We let it be 2 for n is equal to k. So we have this relationship over here. Now we add 1 over 1 plus 2 plus 3 up to k plus 1 to both sides. So left hand side becomes 3k plus 1 and right hand side is this expression over here. And then we solve this. Okay. So this sum is k plus 1 times k plus 2 by 2. So now we solve this, we get 2 times k plus 1 by k plus 2. Hence by induction we have the result. Question 18 says that show that 1 minus 1 over 2 square times 1 minus 1 over 3 square up to 1 minus 1 over n plus 1 whole square is equal to n plus 2 by 2 n plus 2. So as usual, we let it to be equal to Pn and we put n is equal to 1. So left hand side becomes 1 minus 1 over 2 square, that is 3 by 4. And right hand side becomes 1 plus 2 over 2 into 1 plus 2, that is 3 over 4. We let the given expression be true for n is equal to k, so we have this. And then we multiply both sides by 1 minus 1 over k plus q whole square. So left hand side becomes pk plus 1. And right hand side becomes k plus 2 over 2k plus 2 times 1 minus 1 over k plus 2 whole square. And thus we have the result k plus 3 over 2k plus 1, that is for right hand side. And hence by induction we have proven the result. Question 19 says that show that 1 times 3 plus 2 times 3 squared up to n times 3 to the power n is equal to 2n minus 1, 3 raised to the power n plus 1 plus 3 over 4. So we let given expression be Pn, we put n is equal to 1, left hand side becomes 3 and right hand side becomes 2 into 1 minus 1 times 3 to the power 1 plus 1 plus 3 over 4, which is equal to 12 over 4, which is 3. So it is 2 for n is equal to 1. We assume that it is 2 for n is equal to k, so we have got this expression over here. Now we add k plus 1 times 3 to the power k plus 1 to both sides. Left hand side becomes pk plus 1 and right hand side we have here. Okay. And then simplify right hand side, we get 2 times k plus 1 minus 1 times 3 to the power k plus 2 plus 3 over 4. And hence again we have proven the induction by value. Question 20 says that show that cos alpha plus cos 2 alpha 2 cos n alpha is equal to sin n alpha by 2 times cosec alpha by 2 times cos n plus 1 alpha by 2. So if you don't know trigonometry yet, then you should come back to this problem later. We let the given expression be Pn and we assume, we put n is equal to 1. Left hand side becomes cos alpha, right hand side becomes sin alpha into cosec alpha by 2 into cos 1 plus 1 alpha by 2. Sin alpha by 2 and cosec alpha by 2 will get cancelled, and this is cos alpha, which is 2 for n is equal to 1. Now we let that it is 2 for n is equal to k, so we have this expression here. So we add cos k plus 1 alpha to both sides. Left hand side becomes, there should be a single is equal to here. Left hand side becomes equal to pk plus 1 and right hand side becomes sin k alpha by 2 cosec alpha by 2 cos k plus 1 alpha by 2 plus cos k plus 1 alpha. Now what we do is we take out half cosec alpha by 2 here. So this first term here, this one gets multiplied by 2 and this gets multiplied by sin alpha by 2. So now we do trigonometric manipulation and finally we arrive at cos of alpha by 2 cos k plus 2 alpha by 2 into sin 2 plus 1 alpha by 2. And that's why induction is proven. Now I will show you the website. You can come to westernwork.org. You can come to westernwork.org. You can download the algebra, trigonometry, and coordinate from these links. Note that the downloaded files will not have dates, so you should add this date, and repeatedly come within 15 or 30 days once, and you can see if the book has been uploaded. If you want to ask questions, then you can come ahead and click the second link and create a login here, and we have tags, algebra, calculus, geometry, coordinate geometry, probability. You can ask questions related to these subjects, and I'll be able to answer that. So that is if I can. Okay. So with this, we end this video here, and I hope that you are enjoying this series of playlists. So if you have not watched earlier videos, go ahead and watch them. There are more than 200 videos. So thanks a lot for watching the video, and I'll see you in the next one tomorrow with 10 more problems. Till then, enjoy your day, keep learning, and sayonara.